Today, we're going to dive into a story that starts with a huge global conflict and ends right in your kitchen. Yep, we're talking about the ultimate high-precision cooking battle, induction versus gas, all sparked by a massive energy crisis. Let's get right into it.
I mean, just think about that for a second. It's a pretty wild question, right? But it's the reality at the very heart of this global energy crisis. How on earth can a single, super narrow strip of water become this massive flashpoint, sending shockwaves that you and I feel everywhere?
So, here's how we're going to break it down. We'll start with that global choke point, then trace the economic fallout. We'll see how that chaos creates a real risk in your own home. And finally, we'll explore the engineering that can build us a much more resilient and independent future. All right, let's start at the epicenter of it all. How did this one little passage become the fuse for a legitimate worldwide crisis? Well, here's the rundown. It all kicked off on February 28, 2026. Military strikes on Iran triggered a really swift retaliation. Iran's Revolutionary Guard warned all vessels to stay away, and just like that, they created a blockade on the Strait of Hormuz, which happens to be one of the most critical energy arteries on the entire planet.
The impact was, immediate and just staggering. Shipping traffic basically disappeared. We had over 150 ships just anchoring outside the strait, totally afraid to pass through. The flow of energy was choked off, kicking off the biggest disruption to the global supply since the energy crisis way back in the 1970s.
Now, an energy disruption on this scale, it doesn't just stay in one place. Let's follow the financial chaos as it rippled out, almost overnight. This number right here, it just captures the sheer speed of the panic. Brent crude oil prices blew past $100 a barrel for the first time in 4 years, and they peaked at a painful $126. That number represents an immediate, massive hit to the entire global economy.
And it wasn't just about fuel. The crisis created this intense financial pressure, especially for developing economies. This chart here shows how borrowing costs, that's the interest governments have to pay on their debt, just spiked. I mean, look at Iraq and Bahrain. For them, the cost of money shot up by over 0.5%, putting a huge strain on their entire national budgets.
So it's pretty easy to see this as some big problem for governments and banks, right? But here's the thing. How does a naval blockade thousands of miles away actually affect the way you cook dinner? Let's connect those dots. This quote, it really says it all. For a country like India, which is the world's second largest consumer of liquefied petroleum gas, LPG, this crisis is a direct threat. Over 80% of the gas that goes into those cooking cylinders comes through that exact choke point. All of a sudden, that blue flame on your stove becomes a geopolitical liability. And this slide right here perfectly illustrates the heart of the problem. A gas stove is just incredibly inefficient. Look on the left. Only about 40% of the energy from that precious, expensive, imported fuel actually heats your food. The other 60%? It just heats your kitchen. Induction, on the other hand, is just a fantastic feat of engineering. It uses an electromagnetic field to generate heat directly inside the pod. It's precise, it's efficient, and it wastes almost zero energy. This is exactly why the response has been so dramatic. Facing this vulnerability, governments are launching programs to convert 8.2 million households from gas to electric stoves. It is a massive, massive push toward electrification, and it's all driven by the need for energy security. Okay, so how do we engineer our way out of this problem? Well, the solution isn't just about swapping out stoves. It's about building a fundamentally different kind of energy system, one that can't be held hostage. The very first step actually happens right inside your home. These high-precision induction cooktops, they need more power. That means you need a dedicated 240-volt outlet. It might sound small, but it's a crucial piece of infrastructure. It's the foundation for this whole switch to a more secure energy source. Now let's scale that idea up, because the real game changer is the community microgrid. Think of it like a neighborhood-level power system. Yeah, it's connected to the main grid, but, and this is the key part, it can disconnect and run all on its own using local sources like solar and wind. That means you get power even when the larger grid is under strain. But, building one isn't simple. As you can see in this diagram, engineers have to do this very careful balancing act between 4 competing goals: keeping costs down, emissions low, efficiency super high, and making sure reliability is absolute. It's a really complex puzzle to solve. But when you get it right, the results are incredible.
Studies of these optimal microgrid designs show they can achieve nearly 92% efficiency. That right there is the power of smart, local, and resilient energy engineering. This is a real, viable solution. So after all that, what does this all mean in the end? This isn't just about a new piece of technology in your kitchen. It's a fundamental move towards what you might call energy sovereignty. So here's the big takeaway. By moving away from that blue flame of imported gas and embracing electrification powered by local microgrids, we get four critical things. We finally break our dependency on these volatile choke points, we slash energy waste with far superior technology, we guarantee power reliability, and we build energy security right here, in our own communities. And that leaves us with one last powerful question. Do we really want our energy security to be at the mercy of a 21-mile waterway on the other side of the planet? Or is that something we can and absolutely should engineer for ourselves right where we live?